So what is the equilibrium, not equilibrium, what is the equation of the period of a spring, which is from the spring lab? So the equation for the period of a spring, period is equal to two pi times the square root of m over k. Capital T is period, which again, remember, period is the time for one oscillation. M is mass. K is spring constant. So, what's the period of a spring in number 6 if it were allowed to oscillate? So I'm going to start by writing down the numbers from number 6. So the spring constant K was 7.84. God bless you. The displacement, X, was negative 0.25 meters. The mass was 0.2 kilograms. And let's go ahead and include the force in case we need it, 1.96. Okay, so I got my knowns and unknowns written down. I'm going to use my equation, period equals 2 pi squared of m over k. What is the period? So I'm solving for capital T. So I just write capital T equals 2 pi times the square root of m over k. So the mass is 0.2. And k is my number from number 6, 7.84. So, first things first, divide 0.2 by 7.84. Gives me period equals 2 pi times the square root of 0.0255. Square root that number. Gives me period equals 2 pi times 0.1597. Multiply that by pi, multiply that by 2. Gives me a period of 1 second. Amazing how that works. It's almost like I planned it that way. Now, I want to point out really quickly. Notice I did not use amplitude and I did not use force. You don't need to know the amplitude. So if I give you the amplitude, you can ignore it. You don't need to know what it is. The amplitude is only helpful when you're finding the force on a spring. We don't want to know the force for 8 at least. And so I don't need to know what the amplitude is. I just need to know the spring constant and I need to know the mass. Okay? If you knew the period and you were solving for one of these, you would have to use your order of operations, divide the 2 pi over, get rid of the square root, that kind of stuff. Which we can cross that bridge when we get to it if you have questions. I believe there's one where you got to solve for mass, maybe. Yeah, number 4, you're going to end up solving for mass. So that's kind of the idea behind these. Okay? All right, let's talk about the practice real quick. So you've already done 1, 2, and 3. Now you're going to finish the practice. I would actually start with number 5, because number 5 is like the example. Number 4 is a little bit different. I would actually start with number 5, then go back to number 4, and then finally finish up by doing number 6. Okay? You got the rest of the period to work on 3 things. Thing number 1 is to work on this